Hello, my name is Christopher Lure, and this is my presentation on the Google Cloud Bigtable. I apologize, my voice is bad. I chose this Cloud Bigtable as my project because this is what Google has been using since mid 2000s to store large sets of data internally. So this is a project that's been behind the scenes at Google for a long time, and they've just recently released the beta in maybe 2014. That's right, 2014. So, what is Google Cloud Bigtable? It's a structured storage solution that stores billions of rows and terabytes of data, and it's accessed by a row key. My project is to read big data from the Common Crawl corpus, which is billions of web pages stored in Amazon S3 with public access. The goal is to move the HTML content into a Google Cloud Bigtable and then provide an API at the row level to get, delete, or create records. I developed a Java program using the AWS SDK and the Google HBase Java library. Here's a slide provided by Google. I've seen this in several of their presentations, and it illustrates the basic data model. This is not a table in a traditional sense. This is a multidimensional sparse map. So each cell is time seriesed, and each of those are the columns are actually called column families, and within a column family you can qualify different data. The intersection of a row and a column family is a cell. When you access a cell, you use a get. When you want to insert data, you use a put. Data is accessed atomically. That's the fourth point here. And as I mentioned before, cells can have different timestamps. The way that the Google Big Cloud APIs work is that if you don't specify timestamp, it brings back the most current version of the cell. There's no such thing as a delete. You can't actually delete the data from the table or from the storage. Instead, cells are marked as tombstone, so the Google APIs will hide the data from you when you try to access it. It won't show the data if you do like a scan on the table or a get. My implementation uses row-level methods to make it easier to write data and read data. And I also implemented a delete row, although all that does is just tombstone the data. This is what a work file looks like. These are zipped and placed on the Amazon S3 storage service. Each work file has a request and response records, and these are large files. So the HTML content is actually in these files, and I'm going to read these files and write the HTML and URLs into the Google Bigtable. There's several dependencies that are required in order to implement this Java program. It's helpful actually to have the Google Cloud SDK installed because it gives you access to the G-Cloud tool, which allows you to create a cluster. And also, if you want to use the HBase shell, which is a command line interface to do things like look at the table content or gets and puts, then you also need the Google Cloud SDK installed. The HBase Java API is what I used in my Java program to communicate with the Google Cloud Bigtable. Okay, here's a screen print of how you could create a Bigtable cluster. I prefer to just use the gcloud command line tool. You'll specify the name, and it'll auto-generate a cluster ID for you. And the minimum is 3 nodes. All these are very expensive. It's about $2 an hour, so you can only run your cluster for a short time. This is a big challenge for me during my development. I had to start my cluster, do some test some code, and then shut it down. That's why the gcloud tool came in handy. I could quickly start a cluster, and then I could shut it down later. Okay, my project name was Crawl Corpus App. This is the app that will enable us to authenticate and talk to the Google Cloud. You also have to generate some credentials using the API Manager. So you download some private and public keys, and you place those on your file system. There's a lot more detail in my full report on how to do this setup. There are 3 runnable programs that I provide in my source code. The first is crawl corpus run. This is the main one, which will read the Amazon data, actually read the work files, uncompress them, and then write to the Bigtable. The name of the table, they call it a tablet, but it's the same thing. The name of the tablet is crawl corpus tab. And then there's 2 secondary runnables. There's the crawl corpus check, which is more than just a Git implementation. It allows you to compare a work file response HTML to a big cloud row that's been inserted, and check the hash code to see if the HTML matches. Just a way to show how the API works. The other one is just a simple unit test in crawl corpus. Okay, here's a look at the code. This is just some of the setup that's involved. You need to modify this HBase site to set your project ID, cluster name, and zone. And that will actually allow this little statement here, connect Google Bigtable to work. And that will authenticate you with your credentials and connect you to the Google Cloud Bigtable Service API. Okay, went over that slide. Okay, the way I implemented this was I used an interface. So there's an interface that the S3 reader uses, basically the main program. When it runs, it calls crawl corpus, and then it implements basically these methods that allow you to create a row, delete a row, or get a row. You can find that in my source code. When you run crawl corpus, it will populate the Bigtable, and you can actually see the data, how much data is getting inserted each time you run it by viewing the Google Developers Console for the cluster. So here I'm just viewing the cluster from the console. Okay, after you've actually run the program, you can also run this optional crawl corpus check runnable. And I've done all of this from the IDE. I don't recommend compiling the jar files down and running them. There's no interface, no website or anything. You just run this from the IDE and you'll get results. And you can see the results in the console. What this will do is this will actually check a work file record against a Bigtable row and see if the HTML that's stored in one matches the other. And the most important thing to do is to delete your cluster when you're done testing, because you get $300 free, but they go fast if you keep your cluster up and running too long. It's very expensive, so make sure to delete your cluster when you're done with it. That's it, and thank you.